Hello everyone, it's September the 19th. Alright. A bit early today, so my last night I was like half asleep throughout, so I really have to do it earlier. Alright, what's this? Minimum operation to reduce x to 0. You're given an integer array nums and integer x. In one operation you can either remove the leftmost or the rightmost element from the array. Of one thing, finally it's not graph anymore. Gosh, all those graphs. Don't you still remember Kruskal? I actually do still remember Kruskal to find the minimum spanning tree. I do. Do I still remember prims? I'm not sure, but it's good. I mean, I think I have one of prims left there, so we can go visit it again. Anyway, let's go back to this. So we can either remove the leftmost or the rightmost from the array nums and subtract its value from x. This modifies the array for future operations. Return the minimum number of operations and reduce x to exactly 0 if it is possible. Otherwise, return -1. Optimal will be taking these two, right? This will be not possible because everybody is larger than 4. Because you're gonna minus, right? And this is going to be 1, 2, 3, 4, 5. Okay. So DP, right? How would you go DP with this if you go DP? So every time you move either left or you move either right, okay? So we can have or you can say basically we want to find, okay, every value is larger than 1, okay? So I want to find a minimum. It's not like you just find a minimum number of elements to add up to 5, right? To add up to 4 on the left hand side, on the right hand side, okay? So let's say we take the first one. Then the question is the minimum of the rest to reach 4, right? If we take again, so the minimum to reach 2, and then we reach 3. And then we say, okay, we take this, right? But at each point, you have two choices, right? You have two choices, which means the state contains a left and a right. Ooh, lordy, a left and a right. So technically, if you go left and right, what's the total number of possibilities? Yeah, it's going to be O(n) squared, which is definitely not going to work. But, yeah, it's like a naive DP. I doubt it will work because you require both. And like every time you can choose the first or you can choose the second. And then you pass into a new state. It may well work, yeah, but I think it will take a long time. If you don't believe it, you can try it. I kind of don't want to try it because I feel like the runtime is bad. So let's see if we can find another way to go for it. We can now sort because we have to use whatever is given to us. We're gonna find a minimum. And you have to go through the outside in, right? So we take a look. But if it's larger than, we just don't go that way, right? So these are trivial cases. The non-trivial is both. And we want to find a minimum, right? Well, I can see the test case. You know, you got all ones, and you got a really giant X here, right? You got, yeah, you got 10 to the 5th all 1, and you got X is equal to 10 to the 9th. 10 to the 5th. Exactly. That's the bad part. We don't want to deal with that. We want to see if there's a easier way. Actually, eventually will be. Hold on. Let's take this as an example. Because eventually we just say we want a sum and a sum, right? And then we want these two to be added together. Which means if we do a prefix sum, okay? Yes, we have something that just sum together. And 6, boom, it's already done. So we cannot go even. So that's it. That's the most we can get from the front. Is 1 and 2. And from the back we have 3 and 5. And then boom, done. So we can say left to right. And don't call it left to right. Let's call this left. And we'll call this on right. Okay. Maybe that's not the best way. Maybe we should go from right to like 3 and 5. Okay, so right. And the length is the number that we need to take, right? The number we need to take. So what we have now is we need something in the front to add something here to add up to 5. All right. And because it's 1, so we can make this into a I see a map. All right, how about map? 3 means you have 1 to take 1. 5 means you have to take 2. Okay. And from this side, and of course you have also 0 means take 0. So from this side we can have 0 means take 0. 1 means take 1. 2 means take 2. Then we go through this thing. Okay? So it goes to 0. We say we have 5. So now I need 2. So it's 2. Go 1, I need 4. We don't have a 4. Go 2, we need a 3. We have 1, so it'll be 3. So minimum will be 2. I think this one will work. This will work. And here on the left it's just gonna be 0, 0. On the right it's gonna be 0 and 0. And then it doesn't exist, so that will be -1. For this will be again 0 will be 0, 3 will take 1, and 5 will take 2. Right? I'm trying to see. Actually, on the left hand side we don't need to, right? On the left hand side we don't need to. On the left hand side it's just be an array, which is totally fine, right? On the left hand side is totally fine, which would just be an array. Be 5, the next one be 25, so it blows up. On the right hand side we have to do it this way. We have to do 0, and then 3 will be 1, and then 4 be 2, and then 5 will be 3, and then 25 blow up. So we go with 0. Do we have a 10? Right? We don't have a 10. 3, we need a 7. We don't have. 5, we need a 5. So we do. So that'll be 3 plus this will be 2. 1, 2, 0, 1, 2. So it'll be 5. All right, that is the solution. I'm pretty confident that is the solution. So if you think about how we get there, well, because we eliminate the possibility of dp, because that's O(n) squared. It's not going to work. So it has to be O(n), O(n) log n. And O(n) log n is going to be like binary search. Just looking at it, I don't see it. Right? And we cannot sort it. So, probably not. And then it occurs to me that when we taking from the left, taking from the right, we're basically doing prefix sum and then suffix sum, right? And they're like, maybe, and then we have to add them together to a value. So that's like a two-sum problem. So that's kind of the thought process. All right, so we need to implement it. So we need a left. All right, let's do a array list. I think it'll be easier. Okay, so new, man. Okay, actually I can initialize it, right? I shall initialize it with a 0. How do I initialize a Jesus? List dot off 0. Does that make sense? Because I only have one argument. Let's see. Left. It tells me to just add it. I was like, okay. I kind of want to avoid doing that, but yeah, I guess it's fine. So on the left hand side is going to be this. On the right hand side is going to be a map, right? Of integer. What the hell? Integer to integer, and equals to new hash map. Okay, just fine. Okay, so I have a left and I have a right. Now we need to, when you say right dot put 0 and a 0. Okay. Now what we need to do is to build. Okay, so we need to build the prefix sum. Okay. Then we say for int I equal to 0. I smaller than nums dot length I plus plus. If nums I, you know what? You don't even need to go through this. I think I can just say for int n of nums, if n plus left dot get left dot size -1, if this is smaller or equal to x, okay, then left dot put add probably should, yeah, int, let's call it last left dot get left dot size -1, and then here we are going to call it last, then add n plus last, right? Else break. Okay, then build the suffix sum, right? We need, actually we can put int last for here, so int last equal to 0, we can say last equal to 0. Okay, then for int I equal to nums dot length -1 I larger equal to 0 I minus minus. Okay, if nums I plus last is smaller or equal to x, then we say right dot put is going to be value last plus nums I, and we're going to put I plus 1. Wait, no. I minus, no, nums dot length minus I, right? So we start with nums length -1, so this minus this plus this will be 1, so start with 1. So we put that, else we will break. I mean, we can probably put this one up there. Yeah, we actually put it there. I larger than 0 and nums I plus last smaller or equal to x. Right, if both, then we do it. Then we don't need this. And oh, we need to update last. Last plus equal to nums I, and then this will just be last. Does that make sense? All right, we add it. If it's good, we update last, put last in it, go for the next one. We didn't update last here, so we have to do that as well. You know what? I kind of like this way, so I will actually do it this way. I think it'll be more fun. Plus, yeah. Oh, because I go last. Nah, that's not fun enough. Let's go this 0i smaller than nums.length and last plus nums I is smaller equal to x. So yeah, it's kind of united the two ways. That we don't have to do this, we don't have to do this. Then we can say last plus equal to nums I. Oh my god, it's going to be exactly the same. Then we're just going to add last. Alright, so these two are the same. The only difference is for the left, we're doing an array. For the right, we're doing a hash map. Everything else is basically the same. So now we're done. Okay, now we're done. What we're gonna do is we'll go through the left. All right, we go through the left. So we say int res. We want a minimum, so we go integer dot max. Okay, then we say for int j. Let's use j. J smaller than left dot size. Okay, j plus plus. So j represents the number we need to take on the left hand side. Okay. So what we're gonna say is x, so target, right? Wait, well, let's get target. Let's go int target equal to x. It's the start. That doesn't matter. We don't have to. So when I say target is gonna equal to x minus nums, not left, j, right? That is the target. Why am I have this? Oh, of course, dot get j, my bad. So that's the target. That's the target. Then res shall equal to math dot dot what? Dot minimum, right? Math dot minimum res. And here is going to be interesting. It'll be j plus right dot get or default, right? Target. And then default value is, if it doesn't exist, then we go integer dot max. And I just realized, I mean, we can simply put this one inside, so we can save a variable. We don't need this, right? So we go through all of them, and we say return res. Return res is smaller than integer dot max value. Then res otherwise minus one. All right. Let's give this one a shot. Correct. Dude, it overflowed. My god. Yep, that's something. It can't use that. Nah, you can't use that. All right, so we know. I know. So the maximum is nums dot length. We do nums dot length plus one, and it cannot be larger than that, right? You have to add everybody together. So if you do that, oh, that is because you use, oh jeez, come on, man, come on. Hold on, let's do our nums. Let's call it max. Nums dot length plus one. Okay, then we'll assign max to it, and we'll assign max to it, but not integer max. It doesn't gonna work. And here we can call that a max. Okay, give this a shot. That one is correct. Okay. And I actually want to try. I know it's gonna be, how many we have? 1, 2, 3, 4, 5, 6. 6, right? So we do 6. And we can do 7. I want to 100. 200, doesn't matter. Just make sure we have these edge cases covered. Yep, I think edge cases are covered. I think we're good to go. Alright, let's go. Boom. So I kind of struggled last time. I'm interested to see. So this is the third time we solved this, and we can just open up all of this. Oh, what I learned today, you can. Okay, I heard today about the number of tabs you can have on a window. I mean, this is using Chromium, so it's just Chrome. At least for Chrome, it's 130. That's what I heard today. A person told me that if you go above 130, the browser will refuse to open a new window. So that's the magical number. Never tried it. Okay, DP is not gonna work because the runtime, because we need 2 indices for state, and that would make the runtime O(n) squared, right? Binary search is not gonna work because it just doesn't feel right. I mean, binary search, we're saying like if we say it contains certain number, then we need to check if it's good or bad, and we'll take maybe because the check, right, for a given number of possible answer is not O(n). It's not. So we don't know starting from where, right? We don't know. Then the intuition is that we are basically doing a prefix sum and suffix sum, and we're trying to solve a two-sum problem with the prefix and suffix sum, right? So we can produce the prefix sum until it exceeds x. We can then produce a suffix sum, right? Produce suffix sum in a map to facilitate two-sum, the two-sum algorithm, right? Two-sum algorithm. So I think that's the first problem in LeetCode. And then voila, we're done. O(n) for sure, and here's our runtime. Okay, good. I think this is pretty much the optimal. Not 100% sure, but I think it's good. But we'll read through what we did last time. This is my initial attempt. Oh, I did binary search. Oh, lordy. How did I even do this? I did a prefix sum first. Sum all elements in nums smaller than x. Prefix sum must include, I equals must include. Presum, so we have a presum minus x. If it's larger than, must include. That means it's too small, right? On plus, well, I think I know what I'm trying to do. I did a prefix sum and everything, right? And then I check if anyone is equal to x, right? So we have a result, so it's, I think this is for an edge case. And then we say must include, so on the right hand side, we start from the rightmost, right? I have no idea why I did this and then did this. It doesn't make any sense. It must include just n minus 1. So we're going to start with the presum. Okay, that presum is sorted. And presum I, so it's on the right hand side. So we include as much as we can to minus x, right? And if it's larger than that, which means we don't have enough, it doesn't add up. It doesn't add up enough. Yeah, I think it just means it's a larger. Presum I minus, because I'm doing I plus equal 1. Wait, no. This is hold a second. I is must include, I is at the end. So at the end, so all of them add together minus x. Want to find its index. If we have an index, so presum this equals presum I minus x. And then this is we found. Right, it's presum I minus presum I index minus 1. So if this minus this, I don't quite understand. So yeah, I'm not gonna spend time. I don't think this is the optimal solution anyway. Prefix sum and num is gonna tell us whether we can add up some What do you mean we mentally append the entire array to the right? And then continue the prefix sum. What the hell? Oh, this gives us a new presum that is twice the length. Now we start from new presum, then go into the right. Each time we compute. Oh, wow. New presum minus x. And see if this value is in any of the... I see. If it is, then we have found another valid set of operations. Continue to do this until we have gone beyond new pre-sum n minus 1. That's not on, because you have to do this, right? You go to this is on here, but this will take time, right? This will take time. Oh, yeah, this is, I don't know, maybe I came up with this one myself. It's actually quite smart. You wrap the array around, right? You wrap the array around. So we want to find a sum of this and sum of this. So we wrap it around. 1, 1, 4, 2, 3. We wrap it around. Then we do a prefix sum, right? We do the prefix sum of the entire thing. And then we can just go for each. I mean, we actually, yeah, we go for just one by one. Each time we go, we see if it's good, right? Each time we go, we see, actually we need a 0 at the front. That's actually gonna make things a bit easier. So each time we'll minus the thing and see if it's in there, right? We'll find, if it is, then we have like a stretch, right? Then we have a stretch, then we can say, okay, this added together. But oh, that's why we have to start from this position. That's why you start from n minus 1. It's required. You start from this position. And then minus to see if we can find this part, right? Because the start, we have handled it already. So we start from this, and every time you find, it will be a cross, right? It will be a cross, and that will be right. Okay. Yeah, I mean, you can append, or you can just do the full thing. Yeah, I think the next one I realized, yeah, you can, it's just a two-sum problem, right? More easy checks. It's fine. What is this one? Official solution. Front and back add up to, that means the value in the middle must add up to. Oh, that's also different. Our goal is to use prefix sum to find which range adds up to. Oh, and we want the largest range. So at the length. It's different, right? So we want the middle to add up to yeah, we have a target. Oh, that's actually a good one. That's actually a good one. Yep. So it's same. Okay, I shouldn't say same, but it's very similar. So we have, 1, 1, 4, 2, 3, right? So the idea, we need this plus this equal to x, which means that the center is the sum minus x. So what we want to do is go, we have a prefix sum, right? We want to know this prefix sum minus sum here will have this return to the sum minus x. So if we keep track of each prefix sum in the index, right? And we have the total, then we just say the total minus, does it exist? If it exists, we can find this. You know what? I want to implement this. This is the same, right? I think it's the same, but yeah, that's fine. That'll be interesting. So this is the is another way, right? Another way to implement something very similar to what we have tried before. So instead of a two-sum problem using prefix and a suffix sum, we can do a two-sum problem still with just the prefix sum. The key idea is that to find some prefix and a suffix sum to equal x is equivalent to find some stretch of the values in the middle adding up to some nums minus x, right? And we can do prefix sum, right? We can do prefix sum, record all the positions of the previous prefix sum, right? Record all the previous prefix sum and do two sum to find where the match is going to be, right? Where the match is going to be. So this probably has an easier implementation. Oh, I just realized one thing. I don't have to, oh, it's actually going to be the same. It's actually going to be the same because I don't need this, okay? I do not need this. I just realized, holy crap. I just realized I don't need this, right? This is not necessary. I need to build a suffix sum, okay? Then we do this, then we do this, which is all fine. And then int j, now we have a last. So we have to reset last equal to 0, okay? So we reset int last equal to 0. No, not int, we just reset last equal to 0, right? And then what we're gonna do is we'll have to get the last out first. Well, we can do that. We can say how are you gonna do that? Last, right? Because j is equal to 0. Oh, we can do res. Yeah, that's what we're gonna do. Last is 0, it's okay. And then res, we'll handle it here. Res shall equal to right.get or default x, just x max. All right, that we handled already. Then we can do this, right? And then we can say last plus equal to, that's not left. That's gonna be nums dot length. And last plus nums j smaller equal to x. So last will plus equal to nums j, okay? Then we say res plus x minus last, right? X minus last. Then I believe it has the plus 1, right? Plus right got, and then if this is smaller, then okay, let's try. Yes, so we can say no need to build both prefix no need to build the prefix sum array. I think it'll be faster because we don't have to build an array. It's not faster. Well, it's fine. That's fine. This is fine. Okay, so what else? Let's try. Let's try the other one. Okay, so that means we will have a hash map still, but don't call it right. Presum positions. Okay, presum positions. We will put presum positions. We'll put 0, 0, right? And then we'll have this. We'll have this. This is all fine. All right, and we need a res int res shall equal to max. That's actually fine. Okay. Now for each one, we need to handle 0 though. I guess it's fine. Right? Because we have 0 in there, then we will have plus equal to, right? As the last. And yeah, let's call it last. I think let me call it current. Current. Okay. And then we say res shall equal to math dot minimum res. Okay, so we have this, right? What we need to find out is if it exists, right? If it exists. So if so target, okay, int target shall equal to, oh gosh, we need to find a sum. The total sum. Int total equal to 0 for int n of nums. Total plus equal to n. Technically, this is a one line. Okay, so we got a total, right? That's, oh my god. That's dirty. We just want to find a total. So that should be total minus x, right? Okay. And now we're going to say the current minus x, right? That has to be in the presum position. So if, let's say presum position dot contains key, okay? If it contains key, then what do we do? If it contains key, then we say int j equal to presum dot get, right? Current minus x. Current minus x. No, target. Sorry, minus target, right? And then we have the j is the position. Right now we have an I. Then we'll know the total is going to be definitely j plus I think it's nums dot length minus I. Okay, I'm not 100% sure. I'm throwing this out just for the heck of it. So I know that hold on. So all the way to I, okay? So this is the prefix sum, and if we do target no, current minus target equals some, so we add all the way add up to this. That's a j. Okay, so that's a j. So what's the center length? Is going to be I minus j, right? I minus j. I think it's I minus j. I minus j, because it's going to be like 0, 1, 2, okay, 3. So if we go 3 and 1, that's 2. So I minus j, yes. So this shall be minus I minus j. Okay, that's that. And we will just keep going until we done. Of course, we have to add new things. So presum dot put current with I. Okay, and at the end, I think we're gonna return the same stuff. Okay, let's give this a shot. Okay, is this one accurate? Nope. Nope. All right, something is not right. Okay, that's fine. That's fine. What did we got wrong? The first one. The first one I got -1. Okay, so this one should be right. 1, 2, 6, 8, 11. 11 minus 5 is 6, right? So we want to find something that add up to 6. Okay, so we start current is 0, and then we say this smaller than this, that's fine, and then we have the current. And current minus target. Current minus target, if it's in, right? If it's not in, we just add this, that is fine. If it is in, then we get the previous key, then that will be minimum number of the length minus I plus j. I have no clue why it's not right, but I know we can just debug this. That's fine. We have int nums equals new int. I mean, technically we don't even have to do this, but I'm intrigued, you know? I think it's interesting to try this solution as well, even though it's, you know, kind of not really helping us, but it's okay. So I will put here. I mean, it's good because I'm really enjoying the debugging actually. So when we get here, x is 5, total is 11, target is 6. I think everything's fine. Then we're just gonna go in. All right, so current, where's current? Current is 1, so we take the first one, right? So current minus target is negative, so it doesn't exist. So I put 1 into it. Actually, can we do this? Yeah. Oh, 1 is not 0, dude. I find out why. Okay. Now we run it. Okay, still not right. That's fine. That's fine. In fact, once you do that, it's actually a different story, right? Because I don't think when you find a j is the number. Yeah, hold on. This one's actually not right. Because we are adding the number. Ah, I see. If we do this, then we shall set the first to -1. Okay. Is this gonna be right? No, it's not right, but it should be -1. This one shall be -1. Okay, this shall be -1. That's fine. Let's just go again. Debug again. Let's see where we got wrong. And let's let it out. Okay, 1. Current now is 2. which is right, doesn't exist. So 2, current is 6. Oh, you have to keep going. My bad. Yep. Sorry. Forgot. We're doing a very different type of algorithm. They have to go all the way to the end. 2. It is 2. Answer is 2. Okay. Now this, I think, shall be right. Yep. It's the same idea. I think the runtime might be the same. What happened? I don't know. I thought it was right. Did we not handle some stuff? I am not so sure. Oh, it's not that much. We can actually test this. The hell? Seriously, what the hell? Didn't expect. I thought this method is very straightforward and you can get it done really fast, but boy, am I wrong. See, that is the beauty of, you know, trying these methods. You have to implement it, you know. You think you're gonna get it, but okay, so 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. I knew it. It's the edge case. So I did not handle the edge case very well. But how? When you get to the last one, current minus target will be 0, right? And if it is 0, we find the position of 0, which we have is a -1. So j is -1. I is nominal length minus 1. So basically, minus nominal length minus 1. So it'll be 1, so it'll be 0. What the hell? Nominal length. So I would expect j. Hold on. So we're saying the prefix sum add up, okay? Prefix sum add up is the whole thing, right? And we are saying that to be something in the middle, right? We want to find something in the middle, right? So it says something in the middle is going to be I minus j. That's something in the middle, okay? I minus j. Now, the something in the middle. Wait, hold on. This, right, minus target. So we want this target. The target is 0. My bad. The target is 0. Okay? The target is 0. I think, oh yeah, the target is 0. And then you do current. Oh, I think I know how. I need to put this one first. No, not this way. Put this one first. Okay? Then we will have it. Yep. Yeah, sorry. A small lapse of concentration. This one shall go here. Then we will get it. Come on. Come on. Come on. Yep. That's that. Like run longer. That's fine. Okay, so yeah, like this problem, we solved it, but yeah, actually, I do think maybe implementation wise, the one that I implemented first, it's not really that bad if you think about it, right? It's not that bad. Actually, it's pretty bad. So we have useless, right? This array list is useless. This one's fine, okay? This one's fine, but yeah, this one does seem to be the best around. Okay, it's fine. All right, done with this, and I need to see this problem. A iterative, right? So I solved it yesterday. I think iterative. That's the iterative. Yeah, it's really stupid because I have to do this one first. We splice the thing out first and then go. So I want to see what the right way to do iterative. New object, stack 0 and 1, and then return the new object. So I put object and is array. If it is array, we'll do this. Otherwise, we'll do this. Okay. Oh, we're putting things in. So we'll pop out. I use the same. So we'll pop out, okay, the current object and the new current object. And I start putting things into the new current object. And I will, for the key in this, value equal to this, that's fine. If not value, I will just use Boolean, right? Which means if it's false, because if it's false, we'll take it out. Otherwise, then we say if it's not an object, then I say if it's an array, right? If it's an array, dot is array, new current object. So if the value is not, so we need to put it in. So I put it in. Otherwise, I add this. And we continue for the next one. And new sub-project is equal to this. Well, we can just do an else. Okay. I think I got it. Let's implement it again. Did I don't know. 2705. Okay, let's go 2705. Where's 2705? 2705. Yeah. All right. So we can do it one more time. Iterative approach, a better implementation of the iterative approach. So the stack, yes, the stack is gonna be object and new object. So when they say is instance, right? When they say object is instance, array dot is array, right? Hold on. Is array, yeah. To check whether it's an array, so we say array. I like that. Array dot is array. Object, if it's true, then we do an array. False, we do an object. Okay. Then while this, then yeah, we can do const. Let result equal to stack, result equal to object. That's where we start. right? Well, this will be current object, next object. Okay, well, pop. Now what? We have the current object, we have the next object. We have to go through everything of this current object, right? Then we say for const key of current object dot keys current object, right? Then const v equal to current object key. Is that fine? I'm actually not sure, because hold on, I don't really think it's for key in. It's not off. For in. Enumerable string properties. Ignore property keyed. So property in this property. All right. So what if I say, const object equal to 1, 2, 3. Show me. Nah, I want to. Just console.log. Now I want this key, right? Key. Key is instance of number, right? Oh, I don't have this. Oh, false. That was false, but that becomes 0. Wait, hold on. Object dot keys. Object. That is true. But what if I go, what if I go object k? What's gonna happen? Oh, that's fine. So I can, this is fine. Okay? Can I do key value in? Probably not in, of object.entries object. And we do key and value. Does this work? It works as well. Okay, so maybe I can just do that. Right, I can just do that. So let's say for const key value of object.entries current object. Now we have key and value, right? Now we say if is false, right? Not boolean v, continue, right? Now v is a good one. V is a good one. Now we need to consider adding something to the next object, right? We need to add something to the next object. How are we gonna add something to the next object? Yeah, let's say we add something to the next object, okay? Then what? We add it to the next object. We will, v, depending on what the v is, right? if V is not an array, or if V is an array, we will that's not next, that's a new object. Okay, that is new object. That is new object. So yeah, with new object, depending on current object, right? If current object is an array, then add the V. But I need to push this to the stack because I haven't analyzed it yet. Right, I push to the stack. Yeah, the new object, we start adding things, and if this is itself is an array, if the value itself is an array, we'll push, right? We'll push it. Right, we'll push it. Well, we'll add it. We'll add it, and then push this up. We'll add it and push it up. But how do we? You cannot reassign, right? Yeah, you add it to the new object, it's fine, but actually, I'm not sure. How do we do it? Right. If it's not object, new sub-object. Dot push new current object. Hey, hold a second. It says if this is this, right? Then we'll put new sub. And we'll push this. So every round, I'll push a new thing into it. And this gets populated. Okay, so I think, hold on. If, right, v instance of object, right? If v is not an instance of object, then we basically say new object window. Then we just say new object array, right? Array dot is array. new object. If it is, then new object dot add v. If it's not, then new object key equal to v, right? Else, if v is an object, okay, if v is an object, then we have to push it into the stack, right? We're gonna push into the stack, but we need a new sub object shall equal to array dot is array v. If it is, then it's gonna be this. If it is not, it's gonna be this. Okay, that's the new sub object. So the stack need to add v and new sub object, but that's not gonna work because whatever change we made to this will not be reflected in the new object. Therefore, we have to do this one more time. Ugh. Right? So it's array.add new sub. Otherwise, this one equal to new sub. Okay? Once we're done, now the new sub object is inside the new object. Right? It's inside the new object. And this is actually not right. This has to be stack 0 and then 1. And then we put the new sub object into the new object. So now when we handle the new sub, when we populate the new sub object, this new object is populated as well. So we do that, and once we are done, right? Once we are done, we'll return res. Okay. Time to figure out if it makes sense. 78. What the hell? New object.add is not a function. What? Why? I checked. Right, array dot is array new object. If it's an array, then we add. I don't understand. Right, what it says I checked, right? Huh. All right, to debug this. Jeez. It's the first one. Well, it's gonna be ugly. It's gonna be ugly. Yeah. It's an array. How are you telling me that it does not have an add? Oh, I know why. Because, dude, how are you so stupid? I was still in the Java land. I am still in the Java land. Man, sometimes I feel like they should standardize all the. You have append, right? And you have add, you have push. Like just decide on which one. And what's C++? What's C++ in push? Is it C++ in push? C++ array like push. What is it called? Push back. Like every language is different. Like come on, standardize it. Standardize it. Yo, you tripping. You tripping. Dude, there's a 10 times difference. My god. My god, my way is stupid. Because I did this. Yeah, if you think about it, I loop it twice, right? I loop it twice. Yeah. Wow. I mean, the solution also very good because it explains why you set up your own stack is gonna be better, is you are not limited to the heap size. But iterative is always gonna be an issue for me. I'm not really that good with unroll a recursion into iterative solution. Wow, this one is, yeah, I'm surprised. Very, very surprised it's that fast. Oof. Rough. How am I gonna do well in the interview tomorrow? It's all JavaScript. We'll make do. We'll make do. But this has actually nothing to do with JavaScript. It's a way to do recursion iteratively. I think, okay. It's the stack, right? It's the stack. I wasn't for sure what should be put in the stack. It's the current value and it's the new value. It's like the return value, right? It's the new value. Yeah. You should put the return value into this. And when you modify it, you modify the previous one. That's what this is. You put this return value, right? And then you start building the return value. This one, understand, right? This is very straightforward. This is the magic, right? This is the magic. So we need to put the return value, right, for the next round into here. But that return value has to be embedded into the current return value. So that's what this one is. Good problem. It's kind of late, so I don't know. Maybe I'll do a couple. Oh my god, there's so many more. There's so many more. I don't know. I'll end it right now. That's it. That's it for today. I'll see you guys tomorrow. Adios.